Okay, welcome back. In today's lesson, we're going to go over this study guide for Unit 17. Is one of the last exercises in the unit before you get ready to take the test. It says, identify one or more of the choices that best completes the statement. Okay, pick all the statements that are true. A is a series circuit. Well, if we look at diagram A, the electricity can flow through light 1, then light 2, then light 3, and it makes a path all the way around. And there's really only one direction for the flow. If we look at circuit B, okay, the electricity can go through lamp 1. It can also go through lamp 2. And so even if lamp 1 was off, it could complete around here through lamp 2, or even if lamp 1 and 2 was off, it could make a path around all the way through lamp 3. So it looks like that series circuit A is a series circuit and B is parallel. So circuit A is series and circuit B is parallel. On this next question, we got this picture of this magnet. Okay, it shows points B and C are the end of the magnet. We know that those are the poles. Point A would be the middle of the magnet where it would be the weakest. And then out here on D, this point is out here in the magnetic field. So which point would the magnetic force be the weakest? Okay, well, B and C, they're the strongest, so those are out. Point A in the middle of the magnet is where it's the weakest. And you can see the field lines are going around point A. Point D is out here in the middle of the magnetic field, so that's not correct. We have 3 circuit diagrams here. We can see that A looks like it's parallel. B looks like it's a series circuit. C looks like it has one light here, before it gets to the first parallel part. So that's kind of odd. And then D is a series circuit. So which circuits are series? B is a series circuit and D is a series circuit. Well, if those two are the ones that are series, then the other two, A and C, are the parallel ones. Which circuits have a switch? Well, this one has one that looks like a door, so it's a switch. C has a switch, and B has a switch. Okay, next page. These multiple choice. A material that conducts electricity under certain conditions is a semiconductor. What kind of energy are you providing when you turn the crank on a simple electric generator? Well, you add mechanical energy here to turn the generator, so it would be A. Electromagnetic waves are produced by, just like anything else, something that vibrates. So let's look. Magnetic fields, no. Electromagnetic energy, no. Charged particle in motion, that sounds right. D, positive and negative charges. So they're all produced by something that vibrates. So C is the one where it says something is in motion, it's moving. The function of a lightning rod. Okay, people put lightning rods on their houses to protect against electricity and send it into the ground. So let's look. Make an object lighter, no. Prevent short circuits in a building wiring, no. Protect a building from damage due to lightning, and that's the one that has lightning in the answer. So that sounds like it's probably a good one. And that's just to produce lightning, no, people don't want to make lightning in their homes. A region around a magnet where the magnetic forces act is called the magnetic field. Okay, magnetic attraction is when they attract. An electromagnet is a magnet made from electricity, and the pole is the end of the magnet. So the area around the magnet is B. What makes an electric motor spin? Okay, let's check. The permanent magnet and the electromagnet have no effect on spinning of the motor. That's not right. It's the changing direction of the current that causes the poles on the electromagnet to switch, and that's what keeps it going. The permanent magnet and the electromagnet constantly attract and repel each other. B sounds like it might be right, but let's check C. The permanent magnet and the electromagnet continuously repel each other, and also, kind of sounds maybe a little bit right. And then the permanent magnet and the electromagnet continuously attract each other. So that's not right. So let's check this. The permanent magnet and the electromagnet continuously repel each other, or they attract and repel. Well, we saw that first they attract and then they repel, and then they attract and then they repel. So it's B. The purpose of the commutator in an electric motor is to make this happen, to make it constantly attract and repel each other by switching the direction of the current. It reverses the direction of the current in the electromagnet to stop the motor spinning. No, it reverses the direction of the current in the permanent magnet. The permanent magnet doesn't have current. It reverses the direction of the permanent magnet. No, it reverses the direction of the current in the electromagnet to keep the motor spinning. That is true. Remember, when it changes the direction of the current, it changes the poles on the magnet. So they were attracted to where they're going. And when they get there, it switches direction and they're repelled and they're attracted to the opposite side. An electromagnet would most likely be used. Okay, now this, is a big magnet. You got to hook it to a battery. You have electricity going through it. Okay, so a pocket compass would be, no, that would be a permanent magnet. Ski lift, it has a wheel that turns in a motor. A refrigerator decoration, the device on the end of a crane to lift junk cars. Yes, because you could turn the magnet on, run the electricity through it, pick up the car, move the car, turn the electricity off, and then drop the car. A particle of electromagnetic radiation is not called broadcasting. Protons are in the nucleus of an atom. The nucleus of an atom has both protons and neutrons. Photon was that light particle that we said moves with electromagnetic radiation. An example of a conductor is something that allows electricity and heat to flow easily. Metals are usually good conductors. A, aluminum is a metal, so that sounds correct, but let's check. Plastic, no. Glass, no. Wood, no. Okay. Page 16, what would happen if you break a magnet in half? When you break a magnet in half, remember all the atoms in the magnet are lined up in the same direction. If you break it in half, well, then you just have two little magnets. So one half will have a north pole and the other half have a south pole. No, because all the atoms in each half are still aligned. Neither will be able to attract or repel. No, each half will be a new magnet. That is correct. Neither half will have a pole. What does a transistor do? We said a transistor does not convert analog to digital, allows current to flow in only one direction, amplify change in electric signal, or combine thousands of diodes. We said in the notes it was C. What would happen if the switch in circuit B, so here's circuit B, and in order for the electricity to come along, it goes to the switch. And if it can't make it through the switch, it won't get to 1. It can't make it out to 2. And it can't make it out to 3. So all the bulbs would go out. Not just bulb 2, not just bulb 1, and not just bulb 3. In circuit A, over here, this series circuit, which bulb would be the brightest? Well, the one where the electrons get to it first. So it would be 1. And you increase the strength of an electromagnetic field by increasing the thickness of the insulation on the wire. That doesn't even make any sense. Using a stronger material for the core, that makes sense if you started off with a better core. Decrease the number of loops, no. And decreasing the current, no. Moving charges like those in electric current, remember we saw that video, they produced a magnetic field and it affected those iron filings when that guy dropped it on that plexiglass sheet. An ampere is a measure of electric current, okay? Celsius, or Kelvin, or Fahrenheit is for temperature. Magnetism, we didn't even talk about a unit for measuring magnetism or electric charge. Okay. For charges to flow in a wire, it always has to be connected in a closed path called an electric circuit. So that would be B. Resistance is measured in ohms. At which point would the magnetic field be the strongest? We said it's strongest at the poles, so we're looking for one that says B and C, which is choice B. Okay. And here we have another picture of this magnet with its field line. Point D is the region called, well, out here, this is called the magnetic field. So that's choice B. An electric current will always flow. Everything in science flows from high to low. So let's look from high to low voltage. That sounds correct. Let's check the other answer. Towards the north, low to high, nothing flows from low to high, and towards the south pole, no. Function of an electric motor is to change electrical energy into mechanical energy. It takes the electrical energy and it makes something turn. So to change mechanical to electrical, no. To change electrical to mechanical, that sounds right, but let's check the other choices. Electrical to chemical, no. Chemical to electrical, no. For an electromagnet to attract and repel a permanent magnet in a speaker, so it has to attract and repel, then attract and repel. That means the poles have to switch somehow. The noises sent through the speaker must be loud. It has nothing to do with electricity. More coils are added to the magnet. That would make it stronger. That would make it switch. An electric current must reverse directions. That's what changes the poles on the electromagnet. So that sounds right. Electric current must be turned on and off. No, that'd just make it attract and then not. So we wanted to attract and repel, so we had to switch the direction of the current. A path that has only one route for the current to follow is called series circuit. And we got to be careful because this one says parallel current, this one says parallel circuit, this one says series circuit, and this one says series current. It's called a circuit, so it has to be B. You got to read carefully because two of them say series. The loss of static electricity when electrons move off an object is called static discharge, and that's also what lightning is. Magnetic poles that are alike poles repel, unlike poles attract. So it would be C. What causes electric current to flow? The voltage difference. That's the push or the pressure. And remember, in our water analogy, electricity is what we call the flow of electricity. Energy being magnetism, it's the voltage difference. We said that was the pressure, the push on the electrons. Every magnet, regardless of its shape, has two poles, a positive and a negative, or a north and a south. It has two D magnetic poles. Charge of a proton, we had positive protons, neutral neutrons, and negative electrons. Positive, and the charge of an electron is negative. That sounds correct. Let's check the other ones. The same as electron, no. And change according to the situation, no. And it's not negative. All right. So on the last page, a circuit that has two or more separate branches for current to flow is parallel. So that's series circuit diagram, electron circuit, parallel. Okay, which one of the following shows the arrangement of atoms in a magnetic material that is a magnet? Well, these are jumbled up, so E is wrong. A, they're sort of like, you can see we got a south and a north. Here we got a north and a south pointing sideways. So these are not all aligned in the same direction. These are all aligned with the north and south going across all in the same direction. So C would be correct. The domains are all aligned in a magnet. In a parallel circuit with three bulbs, A, the current from each bulb has its own path to follow through the circuit. The bulbs must all be located on the same branch. That's not true. Overall resistance decreases if a new branch is added. That's not true. There's only one path. That's not true. The current from each bulb has its own path through the circuit. That is true because that's why we can turn one off and not all of them. A magnet made from cobalt, iron, or nickel. Okay, this is the iron triad. These were the ferromagnetic materials. So these would make permanent magnets. So A is a permanent magnet. Electromagnets, temporary, it has to have electricity. Lodestone is what they find in nature. And temporary magnet is an electromagnet. So that's wrong. Lightning is low voltage electric current. No. Kill people. Harmless. No. A very large discharge of static electricity. That sounds correct. And a buildup of neutrons. Neutrons have no charge, so that's not either. So we said C. Buildup of the charges on an object is called static electricity. Discharge is when it discharges like lightning. Negative charge, positive charge is called static electricity, D. The Earth has magnetic poles. Because of this, a compass needle always points north. That's D. Atoms in a magnet. Atoms in a magnet, like here. They're all aligned. Aligned according to their magnetic poles, D. An example of a voltage source, we said that's where the electricity comes from. The circuit is what it goes through. A magnet, if you move it in a current carrying wire, still you can make electric current, but that's not a source of voltage. An electric wire or a battery. A battery like that's why they call them like 9-volt batteries. Okay. As in the case of like magnetic poles, like charges repel. So it's D. Charges repel. And that finishes the study guide. I hope you're having a great day, and do your own study guide and then look this over, double check your answers. Hope you're having a great day, and we'll see you next time.